Good morning and welcome to the Johns Hopkins Applied Physics Laboratory in Lowell, Maryland. My name is Dwayne Brown with NASA's Office of Communications. And joining me on stage is John Grunsfeld, astronaut and Associate Administrator for NASA's Science Mission Directorate at NASA Headquarters, Alan Stern, New Horizons Principal Investigator from the Southwest Research Institute in Boulder, Colorado, and Alice Bowman, Mission Operations Manager at Johns Hopkins Applied Physics Laboratory. Ladies and gentlemen, Pluto as never seen before. 3, 2, 1. And now we'll have remarks from Dr. John Grunsfeld.
It's been an incredible voyage. I know many of you the last few days have been participating, but what it all comes down to is an enormous team of people led by Alan Stern, the principal investigator, a big team here at the Johns Hopkins University Applied Physics Lab, Southwest Research, Ball Aerospace, University of Colorado, the list goes on and on, hundreds of scientists, engineers, technicians, people sewing blankets to be able to prepare this wonderful intrepid explorer, the first to visit Pluto and to fly on beyond into the Kuiper Belt. This is true exploration. I'm so glad you're all here to participate in it. And this, whoops, it disappeared. That view is just the first of many, many rewards that the team will get, especially since Pluto didn't turn out to be a relatively featureless planet with a nitrogen foggy atmosphere, and we're scratching our heads, thinking, okay, what are we going to do with that? Pluto has turned out to be an extraordinarily complex and interesting world. Of course, it would be, but that was never a certainty. But now, for the very first time, we know that. And with that, for his first impressions, I'd like to turn it over to Alan Stern.
Thank you. Well, I want to thank John for his remarks and thank NASA for making this all possible. How about that? "50 years ago today, the United States was embarking at the beginning of an era of exploration of the solar system that will live forever in history. 50 years ago today, the first spacecraft flew by Mars. It was called Mariner 4. And I think it's fitting that on that 50th anniversary, we complete the initial reconnaissance of the planets with the exploration of Pluto. A big team of people worked 15 years to do this. They worked under the gun for time. They broke records for low-cost outer planet exploration. They did some amazing feats, and we saw one of them just last weekend in terms of that mission operations rescue of this flyby that produces images just like the one that you saw, and many more that will be raining to the ground beginning tomorrow. But stay tuned. Stay tuned, because our spacecraft is not in communication with the Earth. We've programmed it to be spending its time taking important data sets that it can only take today. And over the next period of about 12 or 13 hours, the spacecraft will continue to take that data, and then it will transmit a message back to the Earth for about 20 minutes at 9 p.m. Eastern Time, in which we'll find out how it's doing, whether it survived the passage through the Pluto system, and hopefully it did, and we're counting on that. But there's a little bit of drama, because this is true exploration. New Horizons is flying into the unknown. And then, tomorrow morning, we should see the beginning of a 16-month data waterfall. You'll be seeing more and more about Pluto beginning tomorrow. But if we could put that image up, which is now the best image, it has a resolution of about 4 kilometers per pixel, which is approximately 1,000 times better than we could do, even with the biggest and baddest gun telescope the Hubble Space Telescope, 3 billion miles away at Earth. New Horizons took that image yesterday, downlinked it to the ground. The bits in that image flew at the speed of light for 4.5 hours, received at NASA's Deep Space Network, transmitted here. The image was opened this morning. And how about a round of applause for that beautiful planet? Now I'd like to invite our Mission Operations Manager, Alice Bowman. Dr. Up to the stage. Come on up, Alice. Dr. Bowman has been leading this project's mission operations from the time that we wrote the proposal to compete to win this project, all the way through development, through launch, and through an epic 3 billion mile journey across the solar system. Alice?
What an absolute honor it is to be here, to be standing here and waiting for those closest approach images to come down. I can't say enough about how thankful I am that NASA allowed us to build and operate the spacecraft here at the Applied Physics Laboratory. We have a large team, and I just happen to be the Mission Operations Manager, but in no way am I taking the credit for this incredible journey. I mean, it's definitely a team effort. We depend upon each other to each do our part and to be the experts in our field. And when I stand back this morning and I just think, I have to pinch myself. Look what we accomplished. It's truly amazing that humankind can go out and explore these worlds. And to see Pluto be revealed just before our eyes, it's just fantastic. And I can't wait until we get these images down starting early tomorrow morning. And of course, the signal tonight that tells us that spacecraft is healthy and has recorded all that fantastic data. So thank you again. Thank you very much.
Okay, it's been a great morning, and obviously the story's not over yet, and you're going to hear more about that and what's going to happen this evening. But before we open it up for questions, I'm going to toss this to Alan. Alan, if you can set up, we have video of something that happened this morning with the science team, I believe.
Sure. Well, John and I were over at the building here on the APL campus where the science team is working. The science team assembled at 5:45 this morning for a chance to see that best image of Pluto and to react to it and to have a little bit of a scientific discussion. And I think we're going to give you a peek into it if we can cue it up. A little behind-the-scenes look, but it's not behind the scenes anymore. You've seen it on this screen, and it's going viral around the world on Facebook and Instagram and probably every other social media as well. And we're very happy to be here and be able to answer your questions as the representatives of this big team and representative of NASA. And Dwayne, it's all yours.
Excellent. Congratulations. Okay, so we're going to open up for questions, and as Alan said, social media, oh my goodness, the numbers are astounding. The world, ladies and gentlemen, they're just totally excited, and the story's not over yet. So what we're going to do here is raise your hand, the media. We're going to start with you. We're going to go to social media, and we're going to try to get as many questions in as possible. So raise them high. Last time I stayed over here a lot of times, so let me start out with Joel. Give your name and affiliation.
Joel Achenbach with the Washington Post. Tell us about Pluto. What are we looking there? Are there mountains? Are there craters. Tell us about what you see.
Sure. Can we cue that image back up? There it is. Okay, so this image is oriented with Pluto's with north to the top, and so the dark regions that you see are near Pluto's equator. The planet is about 1,500 miles across, to give you a scale. It's got a thin or a rarefied nitrogen atmosphere, which you can't see in this image because it's clear, just like looking through other tenuous atmospheres. But what you can see in this image, and it's possible for the folks behind the scenes to actually just make it a larger fraction of the screen, you'll be able to see it. You can see regions of various kinds of brightness, very dark regions near the equator, very bright regions just to the north of that, broad intermediate zone over the pole. And what we know is that on the surface we see the history of impacts, we see a history of surface activity in terms of some features that we might be able to identify as tectonic, indicating internal activity in the planet at some point in its past, or maybe even in its present. And what we also know is this is clearly a world where both geology and atmospheric climatology play a role, because Pluto has strong atmospheric cycles. It snows on the surface. The snows sublimate and go back into the atmosphere each 248-year orbit. Those snows have been observed to move around on the surface, seen from 3 billion miles away. We look at that image, and frankly, if you're a scientist like I am, you want to see all the supporting data. You want to see the topography that we'll get from stereo so that we can determine what's high and what's low. You want to see color data so that we can start to identify the different compositional units. You want to see the composition spectroscopy so that we can determine what those different areas are made from. You want to see the thermal maps so that we can understand are the brightest areas, the coldest areas, for example, where the snow has plated out, or is it some other story that Pluto is trying to tell us? You also want to see higher resolution images, and in fact, by tomorrow, we'll be able to show you imagery with 10 times the resolution of that image, and eventually, as the data continues to come to the ground, we'll have imagery that's better still, dramatically better still, in fact. So there's a lot more to teach us with the data that's coming down, and we just couldn't be happier about the performance of the spacecraft, and frankly, about the performance of the Pluto system.
Other questions? Here.
Emily Lakdawala with the Planetary Society. I noticed that there's also color information in that picture, so I'm wondering if you can tell me first a little bit about the color data that you got, and also if you see any evidence for atmospheric hazes or clouds or anything happening in the atmosphere that you can see in the images.
Sure, absolutely. Could we put up the color image? Is that possible? There's another image that I'm looking for, and if they don't have it backstage, then I'm not able to show it to you. Okay, so on the monitor, it's a little hard for me to see, but we know that Pluto has color variations across the surface. When we stretch those, which is something that our team is working on right now, we'll have a better handle on how strong those variations are, and we expect to be able to show you some of that later in the day. I've looked at that image just very briefly when we were first over in the science work area, and I was looking for evidence of plumes, looking for evidence of atmospheric hazes, and Emily, I couldn't see them. But that doesn't mean that they're not there. You know, a proper analysis of it will require some time, and maybe higher resolution imagery.
Hi, Miriam Kramer with Mashable. First of all, this is very exciting for everybody, I'm sure. But I'm wondering, specifically for Alice, how are you feeling right now, knowing that your craft is out there, you know, flying by the Pluto system, and you won't hear from it for a while? Thanks.
That's a really good question. I haven't had very much sleep. And you know, we always talk about the spacecraft as being a child, a baby, a teenager. And we lost signal as planned last night at 11:17. And there was absolutely nothing anybody on the operations team could do, was just to trust that we had prepared it well to set off on its journey on its own and do what it needed to do. But yet, there were a lot of us in the ops center, even though we knew that that spacecraft wasn't going to be talking to us. But we were there. We wanted to be with it as it went through this journey. And I am feeling a little bit nervous, just like you do when you set your child off. But I have absolute confidence that it's going to do what it needs to do to collect that science, and it's going to turn around and send us that burst of data and tell us that it's okay. So I guess it's a mix of feeling nervous and proud at the same time.
Well said.
Okay, we're gonna, before you ask your question and give your name and affiliation, if you can please raise your hand a little high. A lot of folks here in the lights, so we can get, so go ahead.
Hi, Stacy Severn, Star Talk Radio. And I have a question from one of our listeners. How long can New Horizons continue to transmit before its power expires?
I'll take a crack at that. New Horizons is powered by RTG. That stands for Radioisotope Thermoelectric Generator. That's the same kind of power supply that other outer planet and deep space missions that fly too far from the sun for solar arrays to work. That's what we all use. That's a technology developed jointly by NASA and the Department of Energy. And the actual power source inside the RTG is the element plutonium, which, by the way, was named for the planet Pluto in the 1930s. So we sent a little plutonium back to Pluto. That plutonium produces heat, and from the heat, thermocouples convert that into DC electric power for the spacecraft. When we launched, New Horizons was producing, through that RTG, about 250 watts, but that declines every year as the plutonium decays. And it's currently producing about 202 watts to power the spacecraft and all the instruments. But every year, 3 less watts. And as that declines, eventually we'll get to a point where we can't operate the primary spacecraft computer and the communication system. We've estimated that that point will be reached sometime in the mid-2030s, roughly 20 years from now. At that point, the spacecraft will be approximately 100 astronomical units from the sun. And so over those next 20 years, if the spacecraft continues to be healthy, it could operate and return scientific data, first from a potential Kuiper Belt flyby of a small planetesimal, the building blocks of planets like Pluto, and then we have a chance to go further to explore the deep reaches of the heliosphere like Voyager did, and to do that with much more modern instruments, much more sensitive instruments that are aboard this spacecraft, and hopefully return data that will really add to the storehouse of what we know about our environment in the solar system, and potentially even to cross that interstellar boundary and start to sample interstellar space with this much more modern instrumentation.
Can we go with the gentleman here? Before you ask your question, I'm going to try to get to as many media as I can. If you can help me out here and just ask one question. Don't try to sneak a follow-up in, okay? We can get to as many. These folks will be available throughout the day for one-on-one interviews. So, sir, name and affiliation.
Yeah, John Wenz with Popular Mechanics. I'm just wondering how, when the data comes in, it'll be prioritized. I know there's a prioritization, especially because it's such a slow, almost 56K connection coming back from Pluto. So how has it been sorted to be prioritized as it comes back in over the next few months?
Well, that's actually a nuanced story. So let me start by saying over the next couple of months, the spacecraft, well, for the next couple of weeks, the spacecraft's going to be sending some of the highest priority data back to the ground. But then beginning around the 1st of August, we're going to transition to a mode where the spacecraft is sending what we call our low-speed data sets to the ground. They're not coming to the ground at a lower speed, but they were taken and recorded at a lower speed. Those are easier to plan for. And we chose those to come to the ground first to give Alice and her team a much-needed break from what's been a 6-month historic encounter of 7 days around-the-clock operations. So we wanted to give them a break, and that's why we're going to send the low speed to the ground in August and September, and then they're going to crank it back up. We'll start the planning for that in just a couple of weeks. We've agreed with NASA long time ago which data sets were first priority, second priority, and third priority, and we'll send them down in that order. Initially, we're going to send all of the data down as a browse data set that's compressed on board the spacecraft. by a factor of several so that we can get it down much more quickly. And then, with that safely on the ground, we'll go back and send everything a second time in an uncompressed manner. The entire process that I just described will take a period of 16 months, and so we expect to finish the last of the data transmit in October or November of next year.
Okay, I'm going to take.
Let me
oh,
just
yeah, John.
ask Ellen or Alice, what is the actual data rate? Because I think 56K is much too high.
Right.
Yeah, we wish it was 56K. Well, we call it rate stepping. So as the spacecraft gets, as viewed from the ground, higher in the sky, and as that ground antenna increases in elevation following that spacecraft, we can increase the data rate. So at the lowest rate, at a 10-degree elevation in the horizon, we're at about 1,000 bits per second. Now, when we transition into a spin mode, we can actually get higher rates. And so at the top of that, so the max data rate is about 4,000 bits per second downlink.
Okay, we're going to take 2 questions, and then we're going to go to social media, which is no surprise. It is exploding with excitement. So one question, and then social media. Then I'm going to come over here because I haven't hit this side yet. Go ahead.
Hi, Ken Kramer for Northeast Astronomy Forum in New York, where you'll be next year when you have a lot more data back. And we're very excited, and I'm very excited to be here in Universe today. My question is about the cratering on Charon versus Pluto. Looks like in the images you released a day or so ago, there were a lot of chasms and craters at Charon. And this image that you just showed here shows maybe one crater. I wonder, is that real? Do you see a lot less craters? And why would that be? Why is there such a difference between Charon and Pluto? Thank you.
Well, I think you make a perceptive observation that Pluto and Charon look very different. And we've known that even from the Earth, but now we can see how dramatically different they really are. To my eye, these images show a much younger surface on Pluto and a much older and more battered surface on Charon. As we can actually put numbers to this by counting the craters as a function of their size and compare it to impact models, I hope that we'll actually be able to establish the ages of different surface units on Pluto and on Charon. As to why Pluto looks so much younger, either its internal engine continues to run and there's active processes that are taking place, or those atmospheric processes are themselves covering up the geology and covering up the craters. We'll be able to know that when we get the higher resolution data and the compositional data and the other data sets that I mentioned, because with those various data sets, we can really read the whole story. And it's ambiguous today for a couple of reasons. One, we just got the data. And second, we don't have the supporting data sets to really unravel the whole story. So stay tuned.
Okay, let's take a couple of questions, Chris, from social media, and 2 questions that are reoccurring. What's going on? I'm hearing a lot of buzz on there.
Thank you, I appreciate it. Yes, Chris Blair at NASA Marshall Space Flight Center. As we go through and monitor all the great questions from all our fans staying online with us, first question is from @TechnoMagos, and it is, does any of the surface features on Pluto suggest possible tectonics?
I'm not sure, and that's an honest answer. I think we really have to have a little time to work with the data and to actually look at it carefully on a computer versus seeing it on the screen for a few seconds or on the screens over in the science analysis area for just a few seconds. But we're going to have a chance to do that today, and I think that by the time that the experts take a look, we can report back to you tomorrow with a first analysis.
And one more question, Chris?
Excellent, thank you. And as NASA is always encouraging our youth to study STEM, this question comes from one of our younger fans, from Jessica Lucas. She tweets, my 9-year-old son wants to know how long did it take to build the spacecraft New Horizons?
New Horizons was built in a period of 4 years and 2 months, but that includes the design phase as well as the construction and testing. The entire project from the time that we got authority to proceed from NASA until the time that we launched was 4 years and 2 months, which, by the way, is pretty short for outer planet missions and even for planetary missions in general. But we were under the gun to make the Jupiter Gravity Assist launch window in early 2006, and we were able to do that. And as a result, we were able to make the encounter today. Had we not made that launch window, we would have had to fly another 4 years and not encountered Pluto until 2019. So we were very well aware during the period that we were designing and building New Horizons that there was a big incentive to make that launch window. And the Hopkins Applied Physics Laboratory team, the contractor team, those of us on science at Southwest Research responsible for payload development, I think everybody knew that it was very important. And you know, a lot of people really sacrificed family time, nights and weekends. A lot of other people didn't think that it could really be done, but this team managed to do it, and they deserve a huge amount of credit. They not only built that spacecraft and got it launched in that unbelievably short time, but it's worked essentially flawlessly for the whole 9.5 years.
Okay, obviously I'm not going to be able to get to all of the media questions. Dan, Leone, I'm going to give you the last question, but we're going to take a few more here, and then we'll go to Dan. We're going to have to wrap up. Yes, sir.
Cliff McMurray at Astra Magazine. What is the maximum resolution you hope to get from the pictures you're taking in the permanently shadowed areas with Charon light?
That's a little bit of a difficult question to answer because it depends on some of the subtleties of the data analysis. So first, for those who don't know what the question is about, now that the spacecraft is beyond Pluto, when it looks back at the planet, it's seeing the night side and just a thin crescent of sunlit terrains. But we actually arranged the flyby to occur on a day when Pluto's largest moon, if I can represent Pluto by this cup, the largest moon, Charon, is on the other side, and sunlight is reflecting off Charon and illuminating those night side terrains. So we look back with our cameras at those night side terrains illuminated by Charon light, and we can see in those terrains. However, we're looking back into the glare of the sun now that we're past Pluto, and the sunlight creates various optical effects on the images that can make it difficult to see the details that are in them. The native resolution of those images is pretty good, but because it's so dark, the signal to noise is low, and we'll have to actually add the pixels together in a way that reduces resolution until we build up the signal well enough that we can actually pick out individual surface units. How far we'll have to degrade that resolution in order to get the good signal to noise is difficult to predict in advance because we've never turned the cameras back to look at the sun. We didn't want to risk that during the flight out to Pluto. So we'll have to see what those optical effects are and then see how well we can produce high resolution versus medium resolution imagery.
Kelly Beatty with Sky and Telescope. I know the scientists have been worried that what little atmosphere Pluto has might have frozen out, and you were eager to get there. You mentioned yesterday that you've seen spectral data for frost of nitrogen and methane. Is it, and now that you've seen the picture, is it fair to say that it snows on Pluto?
It sure looks that way.
Pass it down this way. Pass it down this way. Pass it down this way. I got to drive the bus here. And then Leo, then I'll come on over here, then we're going to wrap up here. Go ahead.
Stephen Young with Astronomy Now magazine for Alice. Could you tell us a little bit about the other data you got down last night? Are the memory chips filling up, for example?
Well, last night we downlinked that LORRI image, which you saw on the screen here. And we did monitor how that solid-state recorder was doing, and it actually had filled out a couple of segments. So each segment is 4 gigabits. So since the last contact we had with it, it was starting to fill up that recorder. And so one of the things we'll do tonight is get another look at how much data has been recorded on that recorder and have a good measure of how the observations are going on board the spacecraft.
Leo Enright with Irish Television for Alan. I'm sorry I was broadcasting, so I hope this isn't a question that's already been asked. But just the large-scale picture that we're looking at here, I'm seeing, to my tutored eye, I'm seeing maybe 5, 6 different terrains, regions on the broadest scale. Is that roughly right? And the heart feature, that appears to be slightly different, the left side and the right side, but I'm wondering, is that an effect of the subsolar point, or is there a difference within the heart feature?
Yeah, I would say that we're seeing the same thing that you're seeing, Leo. A handful of individual broad surface units across this hemisphere, and we are seeing a bit of a left-right dichotomy on the heart. When we get color data and other data sets, the composition, we'll be able to say more definitive things about that, but I think you're making the right conclusion.
You have a mic? Where's the mic? Pass it down.
Hi, Robert Perlman with CollectSpace.com. Can you describe what exactly you'll see on the monitors tonight when the signal comes in? What's the Hello Earth data that you're going to be getting in, and what will pop up first?
What will pop first? Is that
What will show up on the screen first?
Okay, so when you establish the handshake between the ground station or the antenna, deep space antenna, and the spacecraft, the first thing that we try to lock is carrier, and that will tell us that the spacecraft is there. The next thing we lock are symbols, and then turbo, which is telemetry. And once we lock the telemetry, we know that the spacecraft is transmitting at the expected data rate. It hasn't switched to some other data rate. And so that's what we will see. It's just ones and zeros, but in our database on the ground, we've mapped that sequence of ones and zeros to say out of lock or locked. So we'll actually see those words appear on the screen. And then we'll start to get real-time data from the spacecraft, not recorded data, but real-time data. And that data consists of the most critical points from all the subsystems on board the spacecraft. Since there's not enough room in that link to send everything down at one time, there's a cycle that telemetry table will go through. And so first you might see points that are devoted to the main computer status, and then you might see points devoted to the guidance and control. So when we intercept that signal, we don't know exactly where in that rotation we will intercept, and so we'll just have to wait and watch that cycle through. And we should have enough time to cycle through a few times on that telemetry table.
Okay, 4 quick questions, please. 1.
Hi, Bobby Russell with Quest for Stars. My social media accounts are blowing up. I have to ask the question, when will we see color data and pictures?
We have color data on the ground right now. And so the science team has been working with that. And I believe that we're going to be able to show you some of that later in the day. But we'll get back to you when we confirm.
I'm Bob McDonald from the Canadian Broadcasting Corporation. Congratulations on closest approach, but that was also the most dangerous time for the spacecraft. If anything was going to go wrong, that was it. In the worst case scenario, if you don't hear from it tonight, how much science do you have at this point?
I don't think that we're going to lose the spacecraft. We've estimated based upon a variety of different experts making numerical models of how much dust and debris might be in the system, the probability of loss of mission. And we set upper limits on that probability of loss at around 2 parts in 10,000. So you could fly hundreds of New Horizons through the system and expect all of them to survive. So it's a very low probability, but we always caution that we are flying into the unknown. As you know, we've been furiously transmitting data to the ground in the last few days, and those are called fail-safe data sets. And the concept behind those fail-safe data sets is identical to the concept used on the Apollo missions, particularly the early Apollo missions. As soon as the mission commander would step to the surface of the moon and say a few words for history, they would immediately collect a first sample. It was called a contingency sample in case something went wrong and they had to terminate the rest of the spacewalk, come back into the lander, and leave. So they had a little bit of something guaranteed. And that's what we've been doing over the last few days. In fact, we designed this more than about 4 years ago. And so we went through and looked at the data sets that had been collected on final approach and selected for each of our primary mission objectives some samples of that data, like the wonderful image that you just saw, but also some color data, some compositional spectroscopy, ultraviolet spectroscopy looking at the surfaces and atmospheres, and some of our particles and plasma data was all sent to the ground. And they've obviously revolutionized our knowledge about Pluto and its satellites already. However, it would be gilding the lily a little bit if I didn't tell you that 99% of the data is still in the spacecraft, and some of the most important stuff is in that. So it would be a great disappointment if New Horizons had been lost to a debris strike. But I think that the spacecraft's going to do just fine. We'll see you at 9 o'clock tonight.
Irene.
Irene Fox with Reuters. It's for Alice. I can't really see you there. Based on the information last night and the readjusted diameter of Pluto, how exactly how close did New Horizons come at closest approach this morning, do you think?
Well, that's really a navigation question. I can tell you that we were 72 seconds early for hitting that aim point. And Alan, do you know exactly what the distance was from the plan? Was 7750 miles.
Our nav predicts, the very latest orbit determination indicated that we were going to be somewhere in the vicinity of about 70 kilometers closer to Pluto than the precise aim point. That's still inside the target box, the target window that we wanted to fly through. We did fly through it, but a little bit off center, well within spec.
Hey everybody, Dan Leone with Space News. I suppose this is a question for Alan. When can we go back to Pluto?
I have secretly been working on a lander proposal. Because I had a pretty good bet somebody would ask me a question like that.
Have you really?
Yeah. I do think that we'll return to the Pluto system. I think that it's so scientifically interesting and so compelling that we'll want us in an orbiter or a lander mission in the future. But doing a mission like that is going to be a lot tougher than New Horizons because we'll want to come to a stop. And that'll mean developing some technology to be able to do that, particularly when we want it also to cross the solar system in a reasonable amount of time and not take 40 years to get there because you need to travel slowly, but to be able to travel fast and then also come to a stop. There are some very good concepts that people have, very preliminary concepts for how we can do follow-up missions. But I think first we need to really see this data come to the ground and analyze it for a period of some years because we don't know the right questions to ask and therefore the right instruments to put on a lander or orbiter. So I really think that it's a little premature. We're all excited too, and we're going to want to send new kinds of powerful instruments there. But I think first the right thing to do is to really analyze the data that we have on the ground and then come to that question a little bit down the road.
Okay, so we're going to have to close out here. I will remind the media, these folks and many others will be available throughout the day for interviews. Just check in with the newsroom. I'm going to turn it over to Dr. Grunsfeld for closing remarks, and then I'll do some programming notes.
Well, I think you've gotten a little bit of a sense of this great adventure of science that we're on. We have a long day before we get to the phone home signal. I'll just mention, because I've been watching it, if you go to eyes.nasa.gov, you can see the Deep Space Network signals. So you'll be able to see when, almost live, when the Deep Space Network is looking, and then follow our story, because we'll certainly keep you informed when New Horizons phones home. Throughout the day, though, we have a series of panels, so you'll be able to hear the scientists actually talking about their first impressions. You've heard Alan's first impressions. You've heard a few from the press here on your first impressions. We all have them, and it's just incredible that we're getting our first views of Pluto and the Pluto system in this high resolution. But I can guarantee with as much certainty as any of us can that the best is yet to come. both from images that you'll see later today that are being worked on, and with all of our fingers and toes crossed, the great images that New Horizons is taking right now that will be telemetered over the next days, weeks, months, in fact, for the next 16 months. And that's only part of the story. What we've seen already from Pluto is that it's a complex, interesting world. Right now, the Dawn spacecraft is orbiting the dwarf planet Ceres in the main asteroid belt, and we found that Ceres is really interesting. Of course, you've all been following Curiosity. There was a lot of discussion before we landed the Mars Science Laboratory. Is Mars relatively straightforward or very complex? And the Spirit and Opportunity rovers gave us a glimpse, and now Curiosity has shown us that Mars is very complex, a whole world, much like the Earth. We have spacecraft orbiting the Earth trying to tell our story, which is even more complex. Our atmosphere is really tough to understand. And of course, the existence of life on Earth forever changed the atmosphere and the geology of Earth. So we're just scratching the surface of our solar system, and there's, of course, much, much more. Juno will arrive next year at Jupiter. Next year, we'll launch both the InSight geophysical monitoring station on Mars and the OSIRIS-REx mission to an asteroid to actually do a touch and go on the asteroid and bring samples back. So this is just the most incredible time for planetary science. And I think it's just fitting that you're all here showing this great interest for this incredible achievement, the capstone event of our reconnaissance of the solar system. Congratulations, Alice. Congratulations, Alan. I hope all of you enjoy the day and learn a lot and communicate it to all of your subscribers and readers, because this is an incredible journey. This is true exploration. I'm thrilled to be here.
Okay. So, social media, follow it on Twitter, This Mission, Facebook, YouTube, and others. The conversation is astounding. And all the information you've heard today and you will be hearing the weeks, months, and years, probably, www.nasa.gov/New Horizons. Ladies and gentlemen, America's space program has written a new chapter in science and exploration. Thanks for joining us.
Thanks, John. Those are great remarks.
It's really the golden era of space.